This is where things get really fun. With contrast coding, now what we're going to do is we're going to interpret and we're going to compute the marginal means and use the marginal means to be able to interpret and to recreate the B's. So when I say fun, I mean, this is interesting. So first thing is I want to just display the marginal means as we've talked about before and you've seen. So these are the means of the dependent variable for all four levels. Remember that this is just a main effects model, and our first coefficient is our intercept. And if I just take the mean of all of the means, the grand mean, I get 0.366, which is precisely what the intercept is for our model. And you'll see here, our intercept is our grand mean. Okay. Next, I want to talk about the B's. Not just B naught, but B1. Let's take a look at B1. B1 is 1.09, and what does this represent? Remember, this is my contrast code for Helmert, and Helmert codes look like this. It's -1 and 1, so it's dog versus cat. And these are my means, and I'm just trying to recreate these so that everybody can see them. You can see them as I'm going through this. So pet C11 is the difference between dogs and cats. All right, now, and I compute this by taking dog, because that's coded as 1, and I subtract out cat. So I get a value that is double my effect. Now, why is it double my effect? Well, as you can see here, I have 1 and -1, and it's balanced by 0. Okay? So what I would like to do is, in order to center it, I can divide that difference in half, and I do indeed get my B value. Okay? So then next, I want to look at my second code, and that is my pet C12. And what is that? That is, C12, that is going to be dog and cat pulled together compared to fish. All right. Now, the difference here is now I get, it's the same thing as where I get a coefficient here minus 3.365. Okay? If I go back up to my results, you'll see that, maybe going too far. There we go. That's right here. It's a non-significant finding, but we're just going to work through these B's, no matter whether they're significant or not. So it's minus 0.36, and that's exactly what I showed you right here. Okay, so how do I find that? So it follows the same logic. If you notice, that's dog and cat pooled together and comparing fish. So if I take a look at my table of means, I want fish minus the mean effect of those two other animals pulled together. So it's my third row minus the mean of these two. And now what I'm going to do is I'm going to divide it by 3. Why am I dividing it by 3? Because, again, the way I've set up the contrasts, I need to offset all of these effects so that they're centered on 0. So you need to think of it as like as a seesaw or a teeter-totter. And when I do that, I recreate my coefficient. And then finally, I have my pet C13. Applying the same logic, now this is pig versus the pooled others. Now think about this for a second before I show you. What would be the denominator? So if I had 2 effects before and I divided by 3, then I had 3 and I divided by 3, well, logically, I now have 4 that I need to divide by 4. So it's this fourth mean, it's the mean of pig, minus the pooled mean, or the grand mean, of 1 through 3, and divide that whole thing by 4. And sure enough, that's my coefficient. So, the point to remember, effects must be centered so that you can get the coefficients from the means and vice versa. So think of when we are estimating these effects, these are mean effects, and these mean effects relate the B's and the marginal means together. Now what we're going to be doing this week is we are going to be working on some data so that everybody can calculate these effects. And then what we're going to do is we're going to work backwards to see if you can calculate some of these other effects, maybe even more complicated effects where you have a mixture. So stay tuned. We have a video following up with this for nonsense coding, interpreting nonsense coding, and that will be the last of the new material for this week, and then we'll have an in-class assignment. So stay tuned for 3 more videos.